Hello. So welcome back. So today we are going to study the images formed by convex lens. I hope you have understood the rules used for forming images by convex lens, and I believe that you are going to try them for concave lens. You practice them. That is most important. That is the basic of ray diagrams. Now today we are going to study the images formed by convex lens. Okay. And so first, now there are different positions of the object, and accordingly the image will be formed. Okay. And so the first position is when the object is placed at infinity. So first thing what we are going to do is we will draw the lens, right? So first for that we will draw the principal axis as usual. And then we will take a certain distance on the compass. Distance is not fixed. You take it and accordingly draw two arcs. Okay, and from the other end, so that they intersect each other. See that the lens is not thick lens. Okay, and practice of this is most important. Okay, now draw the vertical axis. Don't forget to draw that. So that gives you the optical center. And from that optical center, we are going to mark the focal length and 2f1 and 2f2. Okay, so this is f1 for me, and this is f2, and from this 2f1 and 2f2. Okay, so this is f1, this is 2f1, f2, and 2f2. Okay, labeling you can do it. I am not going to do that. Now, the object is placed at infinity. Infinity in the sense, when I consider this, the focal length of the lenses are nearly 20 centimeter, 25 centimeter in that way. Okay, so when I say the object is at 2 meter, so it becomes infinity because it is very large as compared to 20 centimeter or 25 centimeter. That's what it means. Okay, so if I draw the object here, suppose this is the object AB. Okay. Now, all the rays of light which will be coming from that object, these all rays of light coming from the object which is at infinity, they are parallel to the principal axis. Okay. So the rays of light parallel to the principal axis. Okay. So I am considering here. So you can see I am going to consider all these rays parallel to the principal axis. Okay, I have drawn 3 of them. There are infinite. We have just considered 3 of them. Now these rays of light. Now we know the first rule of used for drawing the images. What is that? Rays of light parallel to the principal axis after refraction goes to focus. Yes, exactly. So they will pass through focus. Right? Now, where do the rays they intersect each other? At f2. So where is the image? At f2. What is the size? Point size. Very small or highly diminished. Okay, so here we can write all the given necessary requirements. Position of object, at infinity, position of image, where it is at f2, right? Size of image. Now this table is in your book, but if you write at that particular position now, we remember them exactly. Okay, so size of image highly diminished. or very small or as per the hook point image. Okay, and nature of image. Now rays of light, they actually meet. Okay, so nature of image is real and inverted. Okay, so nature of image is real and inverted. Now, after that, now second position, let us go. So I will rub this image. Now when the object is placed beyond 2f1, when the object is placed beyond 2f1, okay, so we will draw principal axis, regular basis now. Okay, draw the convex lens. Rub all the additional arcs, whatever they are. Draw the vertical axis. That gives us the optical center, and from that optical center, mark f1 to f1. Okay, take the suitable distance as you wish. So this is 2f1, this is f1, this is f2, this is 2f2. Okay. Now the object is just beyond 2f1. Okay. So that means here. Okay. So this is object AB. Now first ray of light. What is that? Ray of light parallel to the principal axis. So ray of light parallel to the principal axis. After refraction passes through focus. Yes. Exactly. Okay. Second ray of light. Second ray of light we will consider, that is the ray of light passing through the optical center. That goes undeviated. That is the easiest one. Okay. So I am taking this. You can see it. Okay. Now the ray of light going through optical center goes undeviated. Now where do the rays intersect? Here you can see. Right? So draw that. The image. This is the image. Now this is suppose A dash, B dash. Can you see the arrows? Show the arrows. Head, arrow head. Okay, so that you will come to know the image formed is inverted. Image formed is inverted. Okay, now, so we will write all the necessary information. Position of object beyond 2f1. Position of image between f2 and 2f2. Size of image, it's not very small, right? So it is diminished, not highly diminished. Now it is diminished. Nature of image, real and inverted. Nature of image, real and inverted. Okay? So this is second, when the object is placed beyond 2f1. Now let us go for the third one. When the object So we will draw the principal axis. Now this is the most crucial and important position of the object. I will tell you why. And you need to be pinpoint accurate, because a small mistake here can give you wrong position of the image. And so you have to be very accurate as far as measurements are concerned. Okay. So try to be that. Okay. Rub all the additional arcs. Draw the vertical axis. Okay, so you get optical center, and now we can have F1, and this is 2F1, F2, and this is 2F2. Now the object is placed at F1, 2F1, exactly at 2F1. See that object is always perpendicular to the principal axis. So this is A, B. Okay. Now the first ray of light parallel to the principal axis. First ray of light parallel to the principal axis, incident on the convex lens, after refraction passes through focus. Yes, exactly. Okay. Then second ray of light, we will choose the same. Will goes through the optical center. Easiest one. Okay. Now second ray of light passing through optical center goes undeviated. Okay. Now you can see the intersection, right? And so the image formed is at 2F2. Okay, slight it has missed. Okay, so you have to be very accurate. On board there is some sort of error in it. Okay, so but then I have got very accurate figure. If it does not, you have to redraw it. Okay, this is the most important position where you get object and image of the same size. Secondly, object is at 2F1 and image is formed at 2F2. So that is most important position, and for that you need to be pinpoint accurate. Okay, a slight here and there will give you the wrong position of the image. Okay, so now information. So what it is: position of object at 2F1, position of image at 2F2, size of image same size, and nature of image real and inverted. Why? You can see it is inverted. See the arrowhead, okay, and see there. So it is inverted. Secondly, rays of light actually meet. So it is real image. Right. Now, after this, now the next position, let us go for the fourth position. When the object is placed between 2F1 and F1. So when the object is placed between F1 and 2F1. Okay. So as usual, draw the principal axis. Okay, draw the lens. Of course, it is convex lens, right? Rub the additional arcs and draw the vertical axis. This is optical center O, and from that let us point F1 to F1. So this is F1, this is 2F1, this is F2, and this is 2F2. Again I remind you that this distance F1, distance between F1 and O, and distance between 2F1 F1 is same thing here. Okay, so please take note of that. Now the object is placed between F1 and 2F1. So where it is somewhere here. F1 and 2F1. Right? So again, ray of light parallel to principal axis, incident on the convex lens, after refraction of light passes through F2. Do you get it? Okay. Then second ray of light passing through optical center goes undeviated. Right? So extend it, my dear friends, extend it. You can see the intersection here. So increase it. Okay? So this is A dash, B dash. This is object AB. Okay? Now, you can see size of the image has increased. Right? So what we can write here, position of object between F1 and 2F1. Position of image beyond 2F2. Size enlarged. Right? Nature same, real and inverted. One thing have you noticed? When we are bringing the object closer and closer to the lens, the image, it is going away from the lens. See, huh? Okay? Now the next position we are going to study. Let us go for the next position when the object is placed at F1. So fifth position, when the object is placed at F1, okay? So object is placed at F1, so first draw the principal axis, then draw the convex lens. As usual, take certain distance on your compass, draw the arcs from both the sides with the same distance on your compass. Mind well that the lens is a thin lens, it is not a thick lens. Okay, now draw the vertical axis. So this is optical center. Mark the positions of F1 to F1. So this is F1, this is 2F1, this is F2, and this is 2F2. Okay, now object is placed at F1. Yes, exactly. Object is placed at F1. So this is object AB. So first ray of light, what it is? Yes, ray of light parallel to the principal axis, incident on convex lens after refraction will pass through focus F2. Do you understand? Right. And second ray of light, simple. The ray of light passing through optical center after refraction passes through optical center undeviated, right? Now you can see it. Now these rays, in some cases you may get it up. It depends what focal length you take it. So some may get the intersection here, but as compared to the focal length of the lens, it will be at infinity. First only I have said. Now here it will take here somewhere. So it will be very highly enlarged in at infinity. Okay. So what we can say is this. Position of object at F1. Position of image at infinity. And size of image highly enlarged. Nature of image real and inverted. Okay. Now we have started from infinity. When it was infinity object, when the object was at infinity, image was at F1, F2, right? That is at focus. When the object came at beyond 2F1, image was between F2 and 2F2. When object was between 2F1 and F1, image was beyond 2F2. And when the object came at F1, image went at infinity. Now one more position. Let us see what happened. This is really interesting. This is really interesting. Just see how the position of the image changes as per the position of object. Now when the object, this is the last position for convex lens, when the object is placed between optical center, that is O, and F1. Okay, so let me erase this image figure. And we will draw the ray diagram. This is the last ray diagram for convex lens. Okay, so draw the lens. Okay, erase the additional arcs, extra arcs which are at the point of intersection. Okay, draw the vertical axis. Draw F1 and F2, 2F1 and 2F2. This is F1, this is 2F1, this is F2, this is 2F2. Okay, so the object is placed between, yes, between F1 and O. This is the optical center, right? So this is the object AB. Now rays of light, first ray, parallel to the principal axis, incident on the convex lens after refraction passes through focus. Exactly. Second ray of light. Second ray of light passing through the optical center goes undeviated. Now you can see here the distance between them goes on increasing. That means what? They are not going to meet on this side. Right? So, what you can do? Reproduce these rays of light backwards. Okay? Like this. Okay? Now, with dotted line. That is not to be said, right? You know that. Okay? So, it comes here somewhere. So, here the intersection takes place. Now, I will draw that. See the arrowhead. This is A dash, B dash. How it is? Yes, the image is erect. Right. Now, one thing I will tell you. Position of object between optical center and F1. Position of image on the same side. On same side of the lens. Size of image enlarged. Now, nature of image, for the first time it will change. What it is? Virtual and erect. One more thing I would like to tell you. Depending upon the focal length, this position of the image will keep on changing. I have got it here at nearly 2f1. It does not mean that you should get there only. Keep this in mind. Okay? You may get it here, you may get it here, you may get it far away. Doesn't matter. Okay? What matters, you are getting on the same side. So as I have said, depending upon the focal length. Okay? So, dear students, I hope that you have understood all the images formed by convex lens. Thank you.